Imagine a rock 5 billion years old, sitting quietly on the dusty floor of Jezero crater on Mars, a rock that once lay beneath the calm waters of an ancient Martian lake, storing secrets of a world that may have been very much alive. Now imagine that rock, weathered and scarred by eons of Martian winds and cosmic radiation, bearing mysterious tiny markings, leopard, spot patterns, and poppy seed textures that look astonishingly similar to what we see in microbial fossils here on Earth. This is not some overhyped science fiction story or clickbait headline. This is real. NASA's Perseverance rover, humanity's most advanced robotic geologist, has stumbled upon something that could turn one of the biggest questions in science on its head. Did life once exist beyond Earth? Scientists are calling what they've seen in this rock, nicknamed Cheyava Falls, potential biosignatures, and if that word doesn't send chills down your spine, it should. Because a biosignature is not just a random rock pattern. A biosignature is something that might point to biology, to the past presence of life. And if this really is one, it could mean that billions of years ago, in that quiet lake on Mars, something was swimming, growing, metabolizing, leaving traces of itself behind for us to find long after it was gone. So tonight, we are going to take a deep dive into this extraordinary discovery. We are going to explore what NASA actually found, how scientists study something as small as a mineral speck on a distant world, what alternative explanations are on the table, what this means for the future of space exploration, and what it means for all of us here on Earth. Because if we confirm that life once existed on Mars, everything changes not just for science, but for philosophy, religion, politics, and the human sense of who we are. To understand why this is so big, we have to go back. Mars has fascinated us for centuries. Ancient astronomers saw it as a wandering red star, a war god in the night sky. In the 19th century, some scientists even thought they saw canals on Mars, hinting at an alien civilization. Those ideas turned out to be wrong, but our obsession with Mars never died. Modern science has given us a more sober, yet perhaps even more exciting picture. Billions of years ago, Mars was not the frozen desert it is today. Evidence from orbiters, landers, and rovers paints a picture of a planet with flowing rivers, lakes, and maybe even oceans. Its atmosphere was thicker, its climate milder, and where there's long, standing water, there is at least a chance for life as we know it. That's why NASA has spent decades sending spacecraft to Mars. Viking in the 1970s, which performed the first life detection experiments, Spirit and Opportunity in the 2000s, which found evidence of past water, Curiosity, which is still exploring Gale Crater and has detected organics and mysterious spikes of methane, and then came Perseverance, which landed in 2021 in Jezero Crater, a location chosen precisely because it was once an ancient river delta, a perfect place for capturing and preserving signs of life. Perseverance's job is clear. Look for signs of ancient microbial life, cache samples, and prepare them for a future mission that will bring them back to Earth. So what did Perseverance find at Cheyava Falls that has scientists so excited? First, you have to picture where this rock sits, on the floor of Jezero Crater, in a region scientists call Bright Angel. This area is like a treasure chest for geologists' layered sediments that tell a story of a calm, standing body of water. Perseverance drilled into a rock there and collected a core sample named Sapphire Canyon in 2024. What the rover's instruments found were these strange, spotty patterns, very small, scattered across the rock's surface like freckles. The chemistry of the rock was equally intriguing. Minerals like vivianite and gragite were present, minerals that here on Earth are often produced by microbial activity in watery environments. To be clear, these minerals can also form through non-biological processes, but when you find them alongside certain textures in the right sedimentary context, it starts to look very compelling. Scientists compared these features to examples from Earth, ancient lake sediments, hydrothermal vent deposits, even microbial mats. The similarities were striking. Using Perseverance's cameras and instruments, they mapped the distribution of the spots, analyzed their composition, and began piecing together a timeline of how this rock formed, was buried, and preserved for billions of years. The result is a hypothesis that these textures could represent microbially mediated mineral growth, basically fossils at the microbial scale, but this is science, and scientists are cautious. You can't just point to a rock on Mars and say, "Look, we found life." Alternative explanations have to be considered and ruled out. Could these spots be just the result of chemical precipitation? Could water flowing through the rock at a certain temperature and pH have created the same pattern without life? Could the spots be the result of diagenesis, changes to the rock after it was buried, or from exposure to radiation and weathering over billions of years? These are real possibilities. The instruments on Perseverance, as advanced as they are, have limits. Their resolution is good but not as powerful as what we can do in a lab on Earth. The rover can't perform every kind of isotopic analysis or detect every type of organic molecule. That's why scientists are so eager to get these samples back to Earth, where we can use electron microscopes, mass spectrometers, and every tool we have to look for patterns that cannot be explained except by biology. Still, the excitement is justified because this is the first time we have a rock that checks so many boxes: the right environment, the right mineralogy, the right textures. If this isn't a biosignature, it's something that looks an awful lot like one. And if it is, then we are staring at the remnants of life that existed when Earth's own biosphere was just getting started. Imagine that two planets side by side in the same solar system, both having life at the same time. That would suggest life might not be a freak accident unique to Earth. It might be a natural outcome when the right conditions are present. The implications are enormous. First, for astrobiology, it means life might be common in the universe. If life started on Mars, independent from Earth, that means the origin of life might not be a rare fluke, but a frequent event. It means that some of the exoplanets we are discovering around other stars, planets with water, with atmospheres, might also be teeming with life, at least microbial. It would force us to rewrite textbooks on biology, geology, and planetary science. Second, for exploration, it would make Mars sample return missions an absolute priority. NASA and ESA are already working on plans to bring Perseverance's cached samples back by the early 2030s, but these missions are expensive and technically challenging. Every new discovery like this strengthens the case to fully fund and support them. It would also have huge implications for planetary protection. If Mars once had life, or still does underground, we must be careful not to contaminate it with Earth microbes when humans eventually set foot on the red planet. We have to protect Mars for science, just as we have to protect Earth from any potential back contamination when we bring samples back. Beyond the science and logistics, there is the human side. Discovering that we are not alone, even in the simplest form, would be one of the most profound moments in human history. It would touch philosophy and religion, challenging some worldviews, inspiring others. It would raise questions. Are we ready to meet life elsewhere? What does it mean for humanity's place in the universe? Some would see it as proof that life is abundant, and maybe intelligent life is out there waiting for us. Others would see it as a reminder of how fragile and precious life is. Either way, it would mark a turning point. There are still challenges ahead. Mars exploration is not easy. Budget cuts threaten ambitious projects. The technical hurdles of retrieving samples, launching them into orbit, and bringing them safely to Earth are massive. Even if we succeed, we have to ensure the samples are kept pristine and analyzed carefully. And even then, science is slow and careful. It may take years of analysis before scientists can say with confidence that what we have is a true biosignature, but that's okay. Science should be slow when the stakes are this high. The goal is not to rush, but to get it right. As we stand today, Cheyava Falls is a clue, perhaps the most tantalizing clue we have ever had. It is a whisper from a distant past, telling us that Mars was once a world of lakes and rivers, a world where perhaps microbes thrived. It challenges us to keep going, to send more missions, to bring back more data, to one day send humans to pick up rocks themselves, and it challenges us personally to think bigger, to embrace curiosity, to remember that we are part of something vast and mysterious. So the next time you look up at that tiny red dot in the night sky, think of that little rock sitting there, holding secrets from billions of years ago, waiting for us to finally understand them. Because if life once existed on Mars, then we are not alone, and that knowledge will change everything forever. And so we arrive at the end of this journey, not with a final answer, but with a question that burns brighter than ever. Somewhere on that cold, rust-red planet, a tiny rock named Cheyava Falls may hold the oldest story ever discovered, a story written by time, by water, and perhaps by life itself. We are closer than we have ever been to answering one of humanity's oldest questions: are we alone? And yet, this discovery is not an ending, it is an invitation to explore, to wonder, to look deeper into the cosmos and deeper into ourselves. If Mars once hosted life, even for a brief moment in cosmic time, then life is not a miracle that happened once. It is a pattern written into the universe. It means that somewhere out there, under the light of another star, another civilization might be asking the very same question we are asking right now. This is why science matters not just for facts and data, but for the meaning it brings to our existence. The universe is whispering its secrets, and it is up to us to listen. So let's keep looking up, let's keep reaching out, and let's keep searching for the truth, because the day we finally hold that proof of Martian life in our hands will be the day we realize that the universe has always been far more alive than we ever imagined.